mode.
Good afternoon, at least here in Nashville, Tennessee. I'm Brian Miller, and this is Anatomy of a Tin Can Statement, Take 2, presented by Rusty Software. So, as I said, my name is Brian Miller. I'm a longtime web developer, but I'm relatively new to the e-learning industry. It turns out I came to the e-learning industry at a really nice time, basically right as Tin Can specification was hitting the 0.95 version. I am maintainer of 3 open source projects, Tin Can JS, Tin Can Java, and Tin Can Prototypes. I am primary developer, maintainer, and now curator of the registry. I am a contributor to the specification, and for those of you familiar with the Rusty Software belief in ping pong, I am an up-and-comer, supposedly, on the ping pong ladder here. I'm going to start off talking about JSON. JSON is particularly important to the Tin Can API specification, and certainly with the anatomy of a statement, because statements are themselves JSON. So first of all, talk a little bit about why JSON. JSON itself stands for JavaScript Object Notation. One of the primary reasons for using JSON is because browser support and therefore library support is very high for JSON. JavaScript is and has been the language of the browser really since the beginning of the web, and so by allowing e-learning to take place in a browser, we use its favored means of communication, and because of that, back-end support has become very high for JSON as well. It's fairly human readable for those of you from the e-learning industry used to XML. JSON is a little bit more human readable than XML has been. It's minimalist, so we can pass a lot of information without a lot of overhead. There's not a lot of string content that has to go along with the actual value that we want to seek. It's arbitrarily nestable. This is another thing that came across from the XML world, but JSON supports it as well, and it's needed to do more complex data structures. It's executable or parsable because JSON itself is actually a subset of the JavaScript notation. It's very fast for parsing and can actually be executed by a browser. It's become incredibly popular. There's a lot of APIs out there in the greater web world that are switching to become either JSON friendly or JSON only. So within JSON, we have several entities. Strings. Strings are quoted, so basically anything that is surrounded by quotes is considered a string. Numbers, booleans, such as true and false, and null are primitives. Essentially, they are not quoted. When we see an open and closed brace, that indicates that we're seeing a JSON object. An object in JSON has a key value pair structure. In other words, we're going to have a left-hand side that's going to be called our key, and on the right-hand side is going to be a value. The key is known as a property in JSON, as well as in JavaScript objects themselves. Keys or properties must be strings, so they will be quoted. This is a bit of a departure from normal JavaScript coding in that keys in an object in JavaScript do not need to be quoted. In JSON, they do. The key value pair separation is going to be done by a colon. The individual key value pairs themselves then are delimited by commas. Values for the right-hand side can be anything, strings, primitives, arrays, or other objects. And where I talked about earlier, the nestability of objects, this is one of the keys where the value can be an object. A set of open brackets instead of braces indicates an array. And an array is just basically a list. And the values of that list, again, can be strings, literals, objects, or other arrays, which means we can arbitrarily nest arrays. Within an array, comma is the delimiter between the values as well. One key with JSON is that white space is ignored. So to compare the human readability versus the minimalist that I talked about on the previous slide, when we're sending JSON to a server, we often want to see all the extraneous white space removed. But on the flip side, when we want to see the JSON as human readability, for human readability, we'll add the white space back in. Some example JSON. This is a simple object, so we see a set of braces at the top level. followed by a set of key value pairs. In the first case, we have a simple property that is a string, and its value is its string as well. Following that, we have a list property that takes an array as a value with 2 strings inside of it. Then we have a Boolean property, a null property, and then a nested object. Now, the property names that I've chosen here can be somewhat confusing. We don't need to use these specific names. They can really be any string value as properties. So those are arbitrarily chosen by me. Another sample JSON with an array at the top level. We can see that this array has 2 objects inside of it, each one with different property. Identifiers. So to go along with JSON and this notion of arbitrarily nested objects, we needed ways to identify those objects. And 2 key components to the Tin Can API statement specification is IRIs and UUIDs. So we can see a fair number of questions about what an IRI versus a URI versus a URL is, and there was even some confusion from the spec contributors recently on this. One of the reasons for using and choosing URIs as identifiers is because they're commonly recognizable by the non-technical. Pretty much anybody who has used a web browser, certainly these days, has seen the URL bar, they've seen a web address, and so they recognize at least the URL. Another couple of reasons for using URIs as identifiers. They allow for domain-specific identifiers. And domain-specific identifiers allows for ownership. So if we allow the choosing of arbitrary IDs, we have no way to specify that that identifier is associated with someone who actually has ownership over the domain. By allowing for ownership, we can claim a particular identifier as ours. By using a URI, we also allow for resolvability because some URIs can be URLs. A URL is a URI that is resolvable, essentially. It is an actual location. So one of the things that Rusty Software has provided is a registry for URIs. The registry is a community effort. We established it and we maintain it, but we're really looking for community contributions. We want to be able to track any and all URIs out there that are being used for Tin Can API statements. Other registries do and can exist. At the bottom of this slide, we can see a couple of examples of URIs. The first one not being typically resolvable. This is actually an example URI from an upconverted statement from the 0.9 specification. The second URI is one that I actually use in Tin Can JS project, and it is actually a resolvable one. So and I'm going to use the term URI. The specification itself actually calls out for IRIs, which is essentially UTF allowed characters inside of a URI. I'm going to use URI because I've been doing this for just too long to switch that easily. So I mentioned the UUID already. Another name for that is a GUID. And a GUID is a generic name for a class of unique identifiers. The UUID, and in this case, specifically the UUID version 4, is what the Tin Can API specification calls for, and that is a single implementation of the generic name GUID. One reason for using UUIDs is because there's very good library support, again, similar to the JSON. UUIDs themselves are particularly important for interoperability in the Tin Can API specification, so that statements will have a single identifier that can be used across systems. We don't have to worry about collisions occurring in 2 different systems or multiple systems. At the bottom of this slide, there's 3 examples of some UUIDs that were randomly generated, or that have parts that are randomly generated. The key with a UUID is that it is expected to essentially never have a collision in all time, essentially. Moving on, another key piece to the Tin Can API kind of fundamentals is a language map. A language map, then, is an object of language code to string mappings. So on the right side, we can see an example of this, where we have a set of braces, and inside that object, we have keys that map to RFC 5646 key codes, essentially. And those key codes indicate a language and then a locality. So in the first case, we have English used by the United States, and then English is used by Great Britain. On the right side is then the values. This gives us a way to do easy internationalization, essentially translations. There is a special language map code that can be used. It's just UND, that is for unidentified languages. So building statements. Now that we kind of have our components in place, we can start to build statements. And I already said a statement is an object itself. So to build a statement, we can start with an empty set of braces. Within that statement object, we're going to have to differentiate between two types of things. We're going to differentiate between properties versus the object types of the values that are going to live in those properties. On the left of this slide, we have a list of properties that are going to occur in a statement, which is ID, actor, verb, object, context, etc. And then on the right side, we're going to have a set of objects that are outlined by the specification that are going to be used as values to those properties, such as agent, group, verb, activity, activity definition, etc. So the first property that's often created when using a statement is an actor, or set when using a statement. So an actor itself is going to take a value of either an agent or a group object. The actor property stores who the statement is about. It is a required property of a statement, and as I said, the value of the actor is going to be either an agent or a group. So before we can go about setting our actor, we need to be able to determine how to create an agent or a group. So an agent object is one representation of a person. So myself, I have innumerable email addresses. I have a couple of Twitter accounts. I have a couple accounts at Google, etc. All of these are different ways to identify me, Brian Miller, as a person. Each one of them is an individual agent. So we need ways to identify an actual agent. Within the specification, there are 4. There's the email address or inbox. There's the inbox SHA-1, which provides a little bit of privacy. We have an open ID, and then there's one special one that's an account. On the right side of the slide, we can see that there are 2 types of agents that I've specified here. One is an inbox agent, which shows my mail to with my email address and then a name property. The second example here shows an example of the account object. And the account object is for creating agents that are arbitrary to any system, and that system is required to have a home page, but that home page is not necessarily resolvable. In this case, I actually picked one that is. So, for instance, at Twitter, my personal Twitter handle is K95BM01. So I can create an account agent that represents myself as the home page with Twitter and then the unique name that I have there. In both cases, I provide the name attribute as a human-readable way to be used in systems. So a reporting system can collect this agent from a statement, and it can print my name out, essentially. A group, then, is a subtype of an agent. For a group, an object type property is then required. An agent can actually have an object type property, but when we see an agent and an actor property, an agent object and an actor property, we do not need to specify the object type. For a group, the object type property must be the word group, capital G. Groups themselves have 2 kinds. We have identified groups, and then we have anonymous groups. The example here on the right is actually an identified group because it has an account property. So a group may have those same properties that we saw with an agent. We can have an inbox SHA-1, open ID, or account, and that makes it an identified group. The difference here with a group is that it also has a members property, and the value for a members property is an array. And within that array, we have a list of agents themselves. A particular note here is that because the members of a group must be agents, we can't have arbitrarily nested groups. The members in the group need to be identified because they're agents, but they do not have to be identified in the same manner. So for instance, a member of a group could have an account as its identifier, and another member of that group could be an inbox agent, for instance. So moving along to building a statement. So I have my set of open braces, and then I have an actor property. And within that actor property, I've specified, in this case, an inbox agent. Moving along to the next property. Next common property in a statement is a verb. And the verb identifies what occurred, or the action. It too is a required property of a statement, and its value is a verb. Generally, when we're coining verbs, we're going to use the past tense. When sending statements, we know that the statement, once it has been sent, for whatever action occurred, has already passed, and that's where the past tense notion comes in. The verbs, there's a vast range of available options, and check our registry for an ever-growing list. A verb object, then, is what we store in a verb property, and it has a required ID property. And why I mentioned IRIs and URIs before is, for instance, the verb ID is a URI value. Along with that ID, we have an optional but highly recommended display property with a language map value. So at the bottom of this slide, I've included the verb for ADL's experienced verb, along with a display language map with US English experienced for using in human readable situation. The spec says that there should be a display, so while it's an optional, it should be best practice to always include it. So continuing building our statement, I have my actor with my agent, and then I have a verb, and this actor myself experienced. We don't know yet what we experienced, which leads into the next property of a statement. So the next property of a statement is the object. And here I've shown that an object can contain multiple types of objects themselves. So the object property then is the target of the action. In our case, for our statement, it's whatever I experience. It too is a required property of a statement. And there are multiple possible types of values here. So we can have an activity, which is probably going to be the most common type. Other options for the object property include an agent group, or a statement reference, or a substatement. We'll see those other types in a few minutes. So starting off with activity as a particular type of object. An activity has a property that is an ID, and it too is a URI. Another property of an activity is the definition, which takes an activity definition object. Within this object, we have a number of optional properties, which is a type. Type is a URI. Activity types is another thing that you can find in the Rustici registry, tin can registry. The name and description are language maps, similar to the display property of a verb, but in this case, we're going to get multiples. There's a more info property that is a URL. It's essentially something where someone can go out and click to get more information about this activity. For those of you used to the SCORM launch world and the LMS world, it's indicated that launch instructions for a particular activity could be stored here. Within the definition, we have an extensions property, which takes a special kind of object that I'll talk about in a little bit. There are some other properties for the activity definition that are particularly related to interactions. Again, something from the e-learning community. There's a lot of confusion around how to create definitions. One key is that a definition is per activity ID. So it can't be changed on a per statement basis. It is expected that the definition will be the same across activity IDs. Now there is possibility for updating those, but it's important to understand that changing the definition of an activity needs to be related to typos and those types of things rather than the actual meaning of that activity. So continuing building our statement, we now have an actor verb, and we show that I experienced, for instance, an activity that has an ID pointing to tinCanAPI.com webinar anatomy of a statement. So for instance, that could be the ID for this slide deck. Within that activity, we have a definition, and the type is media. ADL's media ID here. We have two language maps, again, name and description. In the short one, I have a brief name, and then in the second one, I have a relatively brief description. The length of these is left open. One thing to note at this point is that my statement is spec compliant and it can actually be sent to an LRS. So I have a complete statement here. Earlier I mentioned that an object property can take multiple types of objects. So I wanted to make sure to point out a statement that uses an agent in the object field. So in this case, I'm actually saying that Mike Rustici used the verb hired and pointing to me, my agent. So Mike hired Brian. In this case, I'm using the agent in the object property as well. So I need to specify the object type as agent. Otherwise, an LRS would assume I meant an activity. This statement as well is spec compliant as well for sending to an LRS. So those are the required properties of a statement. Another common property of a statement is the context property, and it's going to take context object that is a special type of object as well. All properties in the context object are optional, and there are a number of them. Context activities is one of the most important. It is an object itself, so we're seeing that arbitrarily nesting again. Within that object, we have 4 properties: parent, category, grouping, and other. These can take either an activity as a value or an array of activities as a value. The parent, for instance, is used to say that one activity is a child of another. So in one specific activity, we would include the parent activity's ID to create a nested or hierarchy structure. Another property is registration. So I mentioned UUIDs already. So registration takes a UUID as its value. And registration is really related to the LMS world, but is essentially there so that we can group statements based on not just the agent or not just the activity, but we can actually say that a particular statement applies to one instance of the experience for that agent, that activity. The instructor and team take agent, group, and or group. In the team case, it must be a group, and the instructor can be either agent or group. Hopefully, those are fairly self-explanatory for their use. Along with this, we can take a statement property in the context. In this case, one use case for using a statement in the context object is to relate to a statement that may have predicted the future. In other words, we could send a statement saying that Brian will do a webinar in the future, and then when I have done the webinar, in the statement saying that I've done it, I may reference the one that I've already completed. A couple other properties. Revision takes a string, as does platform. The language, if known, can specify the RFC 5646 language code as we see in the language maps. And then again, we see an extensions object, which I'll cover in a minute. So building our statement, I've switched out my object here a little bit. Rather than using the ID for the anatomy of a statement slide deck, I'm actually pointing to a particular slide saying slide 37 has been experienced. And within the context here, I have a registration that may indicate that this is the first or second time or third time that I've done this. And then I have the context activity with a parent saying that this slide 37, slide 37's parent is the whole deck itself. Moving on, the next property I'll talk about is the result property, and it too takes a result object. All properties of the result object are optional as well. In the case of a result object, we have a completion and a success properties. Each one of these takes a Boolean. Completion indicates that this activity or this experience has been completed, or not completed if it's false. Again, success indicates that we either successfully completed the experience or didn't. Within this object, we also have a duration, which is an ISO 8601 duration. In the case of using a duration, it's particularly important to note the precision with which that duration is recorded. So for instance, I could record the duration as 1 month, but then someone looking at the statement in the future won't know whether I meant 28 days, 29 days, 30, or 31 days, for instance. So if the precision of a statement needs needs to be paid attention to so that I can say, yes, in the future someone's going to want to know the number of days that was the duration of this statement or this experience. Then I need to specify that ahead of time in the statement. The score property of the result object takes an object itself, so another nested object. Within it, we have a number of numerical properties. We have a scaled property, which indicates a result, a score. So this is something that is particularly measurable. The scaled property itself takes a value between -1 and 1. So this is essentially a way to capture a percentage. The raw value then just takes an actual nominal value. This may or may not be on a range of that can be converted to a percentage. When min and max are specified to additional properties, then the raw value must fit in between those two values. And then again, I've mentioned it before, the result object has an extensions property as well. So building a statement, if I were to give a pop quiz at the end of this slide deck, for instance, then my object might be anatomy of a statement pop quiz with parent as the slide deck itself, and then someone who completed that quiz would have a result. And in this case, it looks like they got a 97, and because it's scaled, we're indicating that that's 97 out of 100%. And this shows a duration of 15 minutes and 32 seconds. Another property of a statement is the ID property, and this is really about the plumbing. This is about making systems that can actually use these statements. The ID property identifies a specific statement. It has a value that is a UUID. The ID property is optional when sending to a statement, which is why I said earlier that the statements that I had on the screen were spec compliant. In other words, I could send them to an LRS. Once that LRS receives a statement, it will set an ID if it was not included. So we have two ways to work here. We can either set our own IDs, or we can allow the LRS to set them for us. The ID property is used in statement reference objects. I talked earlier about the fact that the object property of a statement can take a statement reference as its value. That statement reference will make particular use of this ID property. The ID property can be used to query for single statements out of an LRS. And it provides a primary key for systems, essentially saying we know that this statement is unique within the whole tin can specification, not just for a specific system. The primary key itself enables things such as favoriting statements. It's also necessary for voiding statements. Voiding statements is one example of where a statement reference is used. So looking at a statement that has an ID, this is essentially the same statement that we've been seeing, only I've now added an ID property that is a UUID at the top. To go along with the optional ID property, there's an optional timestamp property. The timestamp is capturing the date and time when a statement is created. Again, the value is an ISO 8601 formatted string. It's optional when sending a statement to an LRS, just as the ID was. If the statement is received by an LRS without a timestamp property, the LRS will set one. At the bottom of this slide, you can see an example of an ISO 8601 formatted string for September 11th at 2:52. And then one key thing about setting the timestamp properties is that they must include a time zone. In this case, we're saying UTC. There is some ambiguity about the timestamp itself. There was recently a discussion on the specification list about this. The timestamp for a long-running duration statement or experience, statement that captures an experience, we may not know whether that timestamp actually applies to the start, middle, or end of the experience. There's some indication that people prefer the end, but there's nothing that can be stated in the specification to make this so. So a statement may be created at the beginning of an experience, for instance, and that would be reflected in the timestamp. So continuing to build my statement, I have my ID. and I've added my timestamp property below it. Now, ID and timestamp are two properties that can be set either by the activity provider or by the LRS. Some properties set specifically by the Learning Record Store or LRS include the stored, authority, and version properties. The authority indicates who asserts the statement. In other words, what account was used to authenticate against the Learning Record Store when that statement was created or stored. The value is an agent or group. When in one use case for using a group here is a group that has two members is used when using OAuth. So if I have an activity provider that is connecting to a Learning Record Store using OAuth, then the authority will be set as a group with the two members that are making the OAuth connection. Another property set by the LRS is the stored property. Stored is the date and time of when the statement is actually stored in the LRS. Again, similar to timestamp, it is a value. Its value is an ISO 8601 formatted string. It should not be used when sending a statement to an LRS. It will be set by the LRS even if it already exists. So this property is special in that it's going to be dependent on the LRS and when the LRS receives the actual statement. It's unrelated to the timestamp. It may be unrelated to when the statement was created. And in the case of statements going from one LRS to another, the same ID, the same statement with the same ID will often have two different stored times. And then finally, there's a version property. And the version property landed in the 1.0.0 spec. It's specifically designed for a single stream of statements so that clients who are receiving statements can easily parse a statement because they know what version the LRS is providing the statement in. So if I were to send the statements that I have been building before and then fetch them back from an LRS, it'll look somewhat like this. So in this case, I've still got my ID, actor, verb, context, and then I've also got my timestamp, but I can see that the statement was actually stored at the same, basically the same time as the timestamp. It has an authority that was a test activity provider to the rest of C software Swarm Cloud with a particular account name. And then this statement was returned by the LRS in 1.0.0 version. The extensions object. I've mentioned this existing in a couple of places: activity definition, context, and result. The extensions property, when used in one of those objects, is a catch-all object. Its properties themselves are URIs. So in all of the cases so far that we've seen, the specification actually indicates what a particular property must be. So a property must be an actor, or it must be the word verb, or it must be the word object. In this case, we're saying that the properties are completely open within the URI space. The values then can be anything, and those values are dictated by whoever coins that particular extension. Again, this is where the ownership comes back into play. So by coining a new extension property, we're saying we own how this will be used, we own how it should be used, and we own the format and the value that goes along with it. Extensions is another thing that can be registered in the Rust of C Software Tin Can registry. And there's already a few out there. For those of you that are following along the design groups, one of the more popular ones that happened on Twitter actually already has a couple of extensions registered in. At the bottom of this slide, I show an extension that is just used for capturing a tweet from Twitter. One more property of a statement that's getting a lot of attention, I think, or at least more attention recently, is the attachments property. The attachments property allows us to define a list of files in an array that will be attached along with the actual JSON body of a statement. Within that array, there is a list of objects, and they have required properties. usage type, which takes a URI. An example of a usage type for an attachment might be a certificate. So if I passed my course and I was awarded a certificate, we can actually scan or auto-generate that certificate and attach it along with the statement that captures that I finished the course. Usage types themselves are URIs. Again, so this is something that we have available to register in the registry. The display, this takes a language map, so similar to the verb display property, an attachment itself will have a display. The attachment will have a content type, so this is a my media type. So if an attachment is a PDF or an image, or it could be text plain, we need to pass that content type along with the actual attachment body. The length, which is an integer, a number of octets, which tells us how long that attachment, or what the size of that attachment is. And then a SHA-2. A SHA-2 property takes a string that is a hash that's used to identify this particular attachment. So for instance, with an LRS, when receiving statements with attachments back from an LRS, that response will be a multi-part response. And in the case of receiving more than one statement, we need a way to uniquely identify all of the attachments so that we can parse the statements and make them match up. Some optional properties of the attachment objects is the description, which again is a language map, and then a file URL. And this tells us a URL for the original source, which may or may not still be resolvable. So just as kind of conclusion, there's a public LRS. It's accessible from the tincanapi.com site, and it's just an instance of our statement viewer. It allows activity providers to send statements in a non-secure, non-private way, and it allows people, community members, to actually go out and see statements easily. So if you'd like to see statements that are being generated by the public, you can go out to the tincanapi.com/public-LRS URL, and you can see statements. By clicking on a statement, you can see the actual raw JSON that's used. Let's see, and I'm going to go ahead and launch a poll here real quick, just about whether or not people have seen or created statements. As this poll wraps up, looks like a fair number of you have seen them but not created them, so hopefully content in these slides will help you with that. Get everybody creating statements. And we'll move along to a couple of questions, I think, here. All right, I'm going to go ahead and close the poll. And we can hear the results here. So got about a quarter that have never seen a statement, a quarter that have created a simple one, and then half that have seen but not created. So that's pretty good. 4% have created a complex one. Hopefully we'll see more and more complex statements come along as TinCan adoption grows. All right, so any question? I know we had a panel of very knowledgeable people, some of which have taught me a thing or two, or 400 things about TinCan API, answering some questions. Let's see, there's one here. Can we discuss attachment URIs in a little more depth? I'm assuming that means, is that the usage type? The attachments has the hash, which I think I covered, is an identifier that goes along so that we can match up a statement which contains the actual identifier itself pointing to attachment, and then the attachment is the file itself. So what we can end up doing is we take a hash of that attachment, which will give us a unique identifier. We put that in the statement, and then when we're recording a statement with attachments, we send both to the LRS. Then when we query back from the LRS, we can get either the statement itself plain based on the query parameters, so the statements API, or we can request back the statement and the attachments, and we'll use that hash for that. The usage type URI is again open. This is something that will be created as the community grows and can be registered. So the example I gave here was a certificate. Another case of attachments that's actually in use by the specification is for statement signing. And then within the attachment object itself, there was a file URL property that can point to the source of that file. So for instance, if we use a generic certificate for all of the participants of a class, perhaps it doesn't have their name in it, for instance, then we could put that URL to the actual source file in those objects as well as attaching the file itself. Let's see, please explain more about the registry. The registry is essentially a resource that Rusty Software as a spec driver wanted to put out there in the world. We got a lot of questions about, hey, I don't know how to coin an activity ID. I don't know how to coin a verb or an activity type. Where do I get these identifiers from? And so what we did is we created a website that you can go on and sign on to, and you can submit for things that need to be curated. You can submit values that you think need to exist. And then those are open out there for the community to find such that they can be used inside of a tin can statement to identify objects. So we have extensions, attachment usage types, verbs, and then activity types are the 4 types that are curated. In other words, we're checking them. We're asking community members, hey, do you think this is a good extension or a good verb? We want to make sure to try and keep the number of duplications down. So for instance, right now there's a discussion around the completed verb. There's an activities streams completed verb and an ADL completed verb. And people are asking questions about, hey, which one do I use, etc. And so that's really what the registry is there to prevent, or at least limit. There's going to be verbs that are collisions. There's going to be verbs that mean essentially the same thing. But by allowing the community to go out and say, hey, this is a verb I'm using, then we can try and keep that to a minimum. There's also an API, web API, that's sitting behind the registry that will be changing slightly, at least relatively soon, and then we hope to leave it fairly stagnant so that tools can actually use that registry's API when they want to provide a list of verbs, for instance. They can make a web service call to the API for the registry and get back a list of verbs. And they may populate their tool with, this is the list of verbs that you can use to create statements. I'm just going through these questions. The tin can work with XML. There was discussions early on in the spec community about making an XML reference standard as well. I believe most people have dropped the efforts there, just favoring JSON. I know there were a number of very large APIs that had both a JSON and an XML format capability, and a couple of them moved to just JSON. So as far as I know, there isn't a lot of work being done there or expectation that there will be work done there. Someone asked if the registry exposed the machine-readable data and API. It does. We will be hopefully presenting some documentation on what that API will be and making it solid so that it will not change in the future, or at least adding a version string so that we can version it for the future. That should come out in the very near term, where I would call the near term, probably a couple, 3 weeks. So look for that to be available. How are JSON statements organized when received by an LRS? That's going to be very LRS dependent. There's a number of hoops that you have to jump through when building an LRS to deal with the different versions, assuming you want to. And it's really up to the implementers of the LRS to determine that. Now, the statement API itself provides a number of ways to receive those statements back, and that's probably the thing that's going to be more important. And so the fields such as stored, or the properties such as stored, is very important when actually making a query to the statements API. Because what we're seeing and what we're expecting to see is very frequently reporting systems, will want to query an LRS to get all of the statements back since a particular time. So they're going to fetch statements in batches, for instance, and they're going to store when they last requested or what the last statement was that they saw, and then periodically they'll request more statements based on that stored property. The LRS will be able to return all of the statements that have been stored since the last request. Yeah, I'm going through a few more of the questions. A lot of these questions aren't necessarily specific to anatomy of a statement, so probably want to try and answer those offline. We will do a post with an answers number of questions if I don't cover them here. Let's see, there's a question about understanding the property of the statement, but how would I connect it to an activity, such as a 5-minute video training on a website? So for instance, if that video only lives or is served on that website, then what I would expect to happen there is you would create an activity object, and the activity object itself will have an ID property that could actually point directly at the file that is that video, or perhaps that video is embedded in a page, and maybe the page is the activity ID there. Alternatively, if you didn't want to be specific to that website or that web page, then you could coin a video or coin an ID for that video that exists under the domain name, but it may not actually be resolvable to the video itself. So for instance, that's how I would do it. Now in the case of video, one of the things that we're seeing is that people are interested in not just the whole watching of a video, but perhaps maybe an activity is the first minute of the video, or the last minute of the video, or maybe there's an activity every 10 seconds in this video. So there's a number of different ways to coin or create activities with activity IDs. One of the keys here, if we're going to do that with a video, where we say maybe we'll send a statement after every minute of that video that they watched, and that's where we're going to use that context object. We're going to want to put into the context activities, we're going to say, you know, the parent of this first minute of a video is the whole video itself. So in that case, we're probably creating 2 different activities. And if there's not a direct parent-child relationship between those activities, then we can use one of the other keys there, perhaps the grouping activity or the grouping context activity property. Could be all of the statements for that video. Someone asked, how do you choose an activity ID? So I just gave a little bit about that. The registry itself allows you to coin activities with IDs that will actually be resolvable. So one of the keys is that all of these things have URIs as identifiers, and they do not have to resolve. One of the recommendations from the specification community is that they will resolve. So a verb could use a URL, which is itself a URI, and it can point to additional metadata about that object. So the registry itself, one of the intended goals is to allow URIs that are being used as identifiers to actually resolve to a location. So any object or any identifier that's coined within the tin can registry from Rusty Software will allow you to actually put that URL into a browser window, hit that resource, and you'll actually get JSON metadata back for that resource. So the same can actually occur for an activity ID. The key with activity IDs is that they won't be necessarily as reusable. They could be reusable, but they won't necessarily be reusable by all of the community, or they may need to be coined by a particular organization or a particular experience. In that case, to prevent collisions within the actual activity space, on the registry, we require a user to create a profile. And then underneath that profile, you can create activities that are coined against the URL that we provide. The example I showed in the slide deck here is under id.tincanapi.com, and then /activity, and then / a profile name, and then you have the rest of your actual activity ID. So one of the easiest ways to coin an activity is to just go into the registry, create a profile for whatever types of experiences you're working with, and then create your activities on the fly, and they will be resolvable, and they will be editable, etc., and long-lived. Let's see, there's a question here: are these statements hand or hard-coded, or will some automated system generate them based on the correct anatomy of the statement? I think that is totally up to you. The specification doesn't actually indicate one way or the other. Personally, I prefer to use a library for such things. So as a developer, I'm going out there and saying, hey, I know I have to create these things. I have to deal with different version differences. I have to deal with these language maps and UUIDs and proper formatting of timestamps, etc. So I'd rather use a library. That's why I'm maintainer of TinCan.js and TinCan.java, which are two libraries out there that are open source. They're available at tincanapi.com/libraries, and they link out to GitHub for those developers that are familiar with it. And so that when creating an activity provider, you can use a standard set of object libraries or a standard API there provided by those libraries that will then convert statements based on version differences. We automatically tag a statement with an ID that is a UUID, and we properly set a timestamp, those types of things. And then the same can be said for actually sending the statement to the LRS. We make sure that all of the details captured in the specification for sending and retrieving statements, etc., can be handled by that library, so that a developer can use one of those libraries and their code can stay the same even as the specification is shifting around them. So I would highly recommend using them. Obviously, I've created a number of statements myself by hand, but I prefer the libraries for anything that's going to be a project that's long-lived. So we're basically out of time here. Thanks for your questions. Again, watch for more blog posts at tincanapi.com, and we'll be answering as many of the questions that I haven't gotten to here as we can. At any point, if you have questions really about anything, which I didn't believe until I started working here, but really about anything, particularly about SCORM or TinCan, feel free to shoot those over to support@tincanapi.com or info@tincanapi.com, or just hit one of our websites. That's about it. Thank you. Questions, comments? We also have a talk page set up if you'd like to get in touch with us and have us get in touch with you. Go out to tincanapi.com/talk. We follow the hashtag TinCan API on Twitter. You may want to follow at Project TinCan, or myself is at K95BM01. And I am actually hanging out, for those of you that are a little old school like I am, there's an IRC channel out on Freenode that is hashtag TinCan API.